Hello. What are you guys studying today? Hi. What are you guys studying? Busy studying Mine Health and Safety Act. Nice, Colin. Let's go. Hi.
All right, friends, welcome back, and let's talk about duration. We have two learning outcome statements here. One is to calculate effective duration and convexity, and then the second one is comparing effective durations for bonds with embedded option vis-a-vis straight bonds. All right, so just a recap from level one regarding duration. Remember, Macaulay duration is measured in time or in
Hi. Oh, you want to become a chartered financial analyst? Um, yeah, mate. I charge like 450 or 500 rand an hour. If you want my info, contact details. So, or you could just ask here and I'll answer for free.
number of years. Modified duration basically adjusts the Macaulay duration by dividing it by 1 plus the yield. And basically gives you the percentage change in price for 1% change in interest rates. And it is applicable when you have a straight bond, meaning no embedded option, because for straight bonds, there is no changes in cash flows in response to changes in interest rate, versus the bonds with embedded options, you could have cash flows change if the underlying option is exercised. Now, we also learned in level 1 that convexity improves the estimated price changes. Because of the relationship between price and yield is not a straight line, it is a curve. Duration is an approximation, and it is only an approximation that works for small parallel shifts in yield curve, small parallel changes in the yield. So effective duration and effective convexity is used for bonds with embedded options. The cash flows can change because of exercise of those embedded option, and effective duration is able to account for that changes in cash flows. All right, the formulas, and you should remember this. You may recall this from before. I'm not too worried about effective convexity. The LOS is really focusing on calculating effective duration, but again, calculation itself of effective duration, we'll see an example, is not that critical. It is more so in tune or in line with level 1 content, but the steps involved here are important to remember, so that you are able to answer qualitative questions. So you have an analyst describing how effective duration is calculated for a bond with embedded option, and there may be an error in one of the steps, and you identify that error. So the steps involved is basically take the bond and you calculate the value, and you remember we compare it to the market price, and to make sure that the value is equal to market price, you estimate the OAS. It technically is done in a very trial and error approach, so you're not going to actually calculate OAS on the exam, but that is step 1. Just remember qualitatively. Then after you calculate the OAS, then what you're going to do is to shock the yield down and up. So negative Y is shocking the yields down, changing the rates in the tree. Every rate you're going to decrease by, let's say, 50 basis points, and then calculate the value. Similarly, do the same with increasing the rates across the tree. After you shock, don't forget, after you shock the rates, remember the binomial tree was benchmark rates. That's why you calculated the OAS in the first place. Now, so after you shock the tree by negative delta Y or positive delta Y, you go back and add the original OAS. Don't change that OAS. Don't re-estimate the OAS. And then we're going to plug in the value. So changing bond value with a decrease in rate versus bond value with an increase in rate. Obviously, when the rates go up, bond value will decline. Inverse relationship between price and yield. So you see the numerator should be positive. All right. Now, comparing the effective duration. Now, we say that duration of bonds with embedded options, whether they be callable or puttable, doesn't matter, will be less than or equal to duration of a straight bond. And that is because the option, the embedded option may be exercised, and if it does get exercised, it will reduce the life of that security. of that bond, that callable or puttable bond. So whether it is less, how far it is less as compared to duration of a straight bond depends on the protection period relative to the maturity of the bond. If the protection period is ending only one day before the maturity of the bond, then the durations will be the same. So depends on the length of the protection period vis-a-vis the maturity of the bond and the probability of exercise of the embedded option. So higher the probability of exercise, the more the spread between duration of a callable / puttable bond versus a straight bond. For a zero coupon bond, the maturity is the duration of a zero coupon bond. And I use this as an approximation because the equality only works if we are assuming continuously compounded rates, but or if we define duration as Macaulay duration, yes, then the duration of a zero coupon bond will be equal to the Macaulay duration of a zero coupon bond will be equal to the bond maturity. Duration of a fixed rate bond will be obviously less than the maturity of the bond, and duration of a floater pays floating interest rate, and the duration of a floater will be approximately equal to time to the next reset. So if the floater is paying semi-annual and and it is 5 more months remaining to the next coupon, then the duration is 5 months. So that is the slide that basically summarizes key takeaways that you need to have. All right, let's do an example using calculation of effective duration. You are given Ernest Smith as a bond portfolio manager. There are 2 bonds, data for which is given to us. Basically, we are going to use the value today, and then you have minus delta y, bond value plus delta y. And it is given for both bonds. Bond X is callable, bond Y is puttable. All right, and you are given the change in yield is 30 basis points. So
Okay, so when rates go down by 30 basis points, the price goes up. And when bond yields are up by 30 basis points, the price should of course come down. So if you want effective duration, we know that formula to be minus 2 times so it's going to be 101 minus 99 2 times no, come on, not 3. Where does that put us? Alright, 2,102.
That is the data given to us. Now we're going to, first question is effective duration for bond X. So again, all of that data is given to us. So BV0, the one that goes in the denominator, is 100.594. Delta Y is 30 basis point. And then we have 100.594. All of that data is, now we're going to
we do bond Y. Coupon of 3.75 nayo, and is also equals to 3. Then it's puttable 1 year from today. No. Then BV0 101 not 3. Then BV delta minus Y. The price should go up. 182. Then BV delta plus Y. The price should come down. So 4, yeah, which implies effective duration is BV minus delta Y minus BV plus delta Y over 2 times BV0 minus with delta Y times with delta Y. I was close with the formula. So it's about 101,882 minus 109.24. 2 times 101,3. 100,003.
basis point. So again, all of that data is given to us. The one that goes up a lot, rates 30 basis down, based the rate split any of that number. So you get a value of 2.21. That's the effective duration of bond X. All right. Now you're asked to calculate effective. Just mechanical plug and chug, mechanical application of the formula. All right, now in interpretation, these are the kind of questions that you should be especially vigilant about. What happens when rates rise?
When interest rates rise, the effective duration of bond X, callable 1 year from today, shortens. Yes, because it's callable 1 year from today. So rather than a duration being close to 3, because it's a 3-year bond, then effectively you can be exposed for less than the 3 years. And then bond Y shortens. Bond Y is puttable. So it's puttable 1 year from today. So the term can be 1 year instead of E3. It does shorten. The underlying option free straight bond corresponding to bond X lengthens. No, effective duration. Don't they both shorten? Oh, no. When interest rates rise, I'm likely going to exercise the option as the holder of the put option. I'm going to sell the bond because when interest rates rise, the bond price comes down and I'm going to sell out. I'm going to reinvest the proceeds into a higher yielding bond because market rates are higher. So that's B.
So remember, bond X is callable. Bond Y is puttable. So when interest rate rises, will the duration of bond X shorten? meaning it will become smaller. Well, no, because when the rates rise, the bond X, which is a callable bond, will be unlikely to be called. Remember, the call option embedded in a callable is more likely to be exercised when rates go down, not rise. So we are given rates are rising. On the other hand, a puttable bond would be more likely to be put option would be more likely to be exercised when rates rise, because it will be in the money. The option will be in the money. Bondholder would want to put back the bond when rates rise, so they can reinvest the proceeds at a higher market rate. Now, the third part is underlying straight bond corresponding to bond X. It doesn't matter, similar straight bond, their duration will increase. Well, when rates rise, duration actually decreases. Remember, our modified duration formula, the one way to remember is the 1 plus y is in the denominator. So when the rates go up, the denominator goes up and the duration value will decrease. And that is for a straight bond. So the correct answer is bond Y shortens. The other answers are obviously incorrect. So that is it for the module on duration, and do plenty of practice questions as usual.
Okay, there's a quiz. Duration ngiyibambile, convexity le ndingayazi. The denominator is wrong. Effective convexity is wrong. Okay, now since I curate duration, yeah. Oh, guys. I'm in South Africa. I don't know what's happening in the United States. They're definitely not saturated in South Africa. Um, Africa is a continent, so I can only speak about South Africa. There's not an oversaturation. In fact, there's a shortage of people in STEM, which is science, technology, engineering, and math. And as a result, people in quantitative fields, there's a massive shortage. Huge demand, very little supply. Where you guys from? Where you guys from? India? Are you guys safe, man? There's a lot happening in the UAE right now, in the Gulf. Okay, I need to make coffee, but I don't know if my milk is still good. I'm feeling good. I'm feeling positive. I'm feeling energetic. I'm feeling productive. I like how I'm feeling. Let's go make coffee. Coffee's ready. Put this away. Studying is hard, but it's enjoyable and it pays off. Oof. I'm studying curate duration and one-sided duration, and I'm wondering, should I do something for my team when I get to work? Because they're really stressed about interest rate movements. I've got access to T-1 bond yields, and prices from the BISA, JSE BISA MTM file. So should I quickly just build them something where they just slide things left, right, and center, to see this kind of thing play out? It will be good for me to learn, but it will also be good for them. Well, it would make me look good, and they would also find it beneficial. So I'm just thinking I'll need access to the data, so I can only do it Monday morning. But let me finish and see. But it's really interesting. So for key rate duration, you just move one key or par rate before the price impact is shifted. Also, I would need the par rates as well. Okay, let me bookmark this. I'm gonna come back to it. I'm gonna use it when I'm for my tea. For the oil shocks. My battery is dying, so I'm gonna log off at 4. Then I'm gonna charge for 30 minutes and come back. I'm gonna bounce, guys, in like 5 minutes. My battery's on 5%. Oh, it's on 4% now. Well, let's try and get to maybe an hour 30. Yeah, let's see. Can wrap up our live nicely, but my battery's dying. When the underlying option is near the money, this is for a callable bond, no? Its effective convexity turns negative, so the upside potential is limited because the issuer can call the bond, whereas the downside risk, um, which happens when interest rates increase and bond prices fall, um, that price is not protected. But if, yeah, when interest rates increase, um, the bonds or the callable bonds are unlikely to be called. Uh, when the underlying option is near the money, its effective convexity turns negative, because the upside. So when it's near the money, it means interest rates are low. Near the money, low interest rates, so it pushes up the call price or the price of the bond closer to the call price, which means its effective convexity then turns negative because the upside potential to me as the bond holder, which is the bond's price, is limited due to the call price, while the downside is not protected. Yeah, whereas, and that's putable bonds, oh sorry, that's callable bonds, whereas putable bonds exhibit positive convexity throughout. Yeah, yeah, I'm definitely gonna make something for my team using this. I think these are my useful. Yeah. Let's do the master class on key rate.
Okay, friend, key rate duration. Remember, when we talked about duration, we said it is applicable only for small parallel shifts in the yield curve. Now, what about changes in the shape of the yield curve or the shaping risk? That's where key rate duration comes into play. We already talked about key rate duration earlier, and we said at that time that we're going to talk about it in more detail later, and that's where we're going to talk about. But first, we're going to talk about partial duration or one-sided durations and understand what they mean. Um, so, the effective duration that we already worked with is good for small, very small parallel shifts in the yield curve. If the changes are higher, then you have an issue with an error in your estimation of percentage change in price or percentage change in the yield because of convexity. And this is true for regular straight bonds also. For bonds with embedded option, it becomes even more problematic because the change is in price is asymmetric. And for a callable bond, for example, when the option is at the money, the convexity actually turns negative. So the change in price when rates drop is very different than for a comparable straight bond. Remember, there is a price compression
it's
for
capped.
a callable bond. It doesn't increase in price because of that negative convexity. So then one-sided duration, specifically the down duration, down and up in this one-sided metrics are referring to interest rate movement. So down duration means price impact of decrease in the rates. So for a callable bond, if the option is at near the money, then down duration is lower. Why? Because the price is compressed at that point. Unlike a straight bond, whose price keeps on going up when rates decrease. But callable bond, there is a price compression when the rates are going down around the call price. So that is why we say when the option is near the money. For a puttable bond, the other way around. Remember, there is a downside protection for a puttable bond when rates rise. So puttable bond will have a higher one-sided down duration. Down duration is when the rates are decreasing, while puttable bond will participate in that upside because there is no short call option embedded there. And it will also have a lower one-sided up duration. Why? Because remember, the price compression for a puttable bond occurs at the put price. So it is not going to decrease below that put price. As compared to an equivalent straight bond or even a callable bond, which does not have that protection. So that is the takeaways. So understand what is one-sided duration. One-sided duration refers to change in price for a decrease in rate, or that would be a down.
Okay, my phone is on 1%. Let's cut this out and then we'll be back in like 30 minutes. I'm gonna charge.